Learning goals. Welcome to this learning session on calculating and using index numbers. In this course, we shall address Introduction to Index Numbers, calculating simple index numbers, interpreting index numbers, using index numbers for new values, and practical worked examples. There will be a quiz at the end to test your knowledge. Introduction to Index Numbers. Index numbers provide a straightforward method for tracking changes in value across different periods. They are essentially specialized percentages that quantify how costs or prices have shifted from one year or period to another. This allows for easy comparison and understanding of trends, such as inflation or economic growth. The core principle of index numbers involves comparing current values against a designated base year or base period. This base year is always assigned an index number of 100, serving as the reference point for all subsequent comparisons. For instance, if a product's price in the base year was £50 and it's now £60, the index number will reflect this change relative to 100. Index numbers are widely used in economics and finance to measure various indicators, including consumer price indices, CPI, which track inflation, and stock market indices like the FTSE 100 or Dow Jones Industrial Average, which reflect overall market performance. These indices help policymakers, businesses, and individuals make informed decisions by providing a clear picture of economic shifts. Calculating a simple index number. To calculate a simple index number for any given year, you compare the cost or price in that specific year, year N, to the cost or price in the base year. This comparison is then multiplied by 100 to express it as an index. The formula ensures that the base year always results in an index of 100. For example, if a laptop cost £500 in 2010, and 2010 is designated as the base year, its index number for 2010 is 100. If the same laptop cost £425 in 2016, we can calculate the index number for 2016 by dividing £425 by £500 and multiplying by 100, which yields 85. This indicates a decrease in price relative to the base year. This method is particularly useful for understanding the relative change in prices of goods and services over time, even when the absolute monetary values might seem complex. For instance, economists use similar calculations to create the Consumer Price Index, CPI, which tracks the average change over time in the prices paid by urban consumers for a market basket of consumer goods and services, providing a key measure of inflation. Index numbers offer a quick way to understand price or cost changes relative to a base year. This section explains how to interpret these numbers effectively. If the calculated index number is greater than 100, it signifies that the price or cost in year N has increased compared to the base year. For example, an index of 110 means a 10% increase. Conversely, if the index number is less than 100, it indicates a decrease in price or cost from the base year. An index of 90, for instance, implies a 10% reduction in value. This simple rule makes index numbers intuitive for quickly grasping trends. Understanding these interpretations is crucial for various applications, from personal budgeting to national economic analysis. For instance, if the housing price index in your city rises from 100 to 120 over 5 years, it means house prices have increased by 20% in that period, impacting affordability and investment decisions. Using index numbers to find new values. Index numbers are not only for tracking changes, but also for calculating actual costs or prices in a given year when you know the base year cost and the new index number. This is particularly useful for forecasting or understanding past values without needing all historical data points. The formula for finding the cost in year N involves multiplying the cost in the base year by the new index number and then dividing the result by 100. This effectively reverses the calculation of the index number, allowing you to derive the actual monetary value. For example, if an investment was £4,000 in 2005, base year, and its index number in 2017 was 108, you can find its 2017 value. Applying the formula, £4,000 multiplied by 108, then divided by 100, yields £440,320. This shows that the investment grew by £320 over the 12-year period. This method is frequently used in financial planning to project future values of assets or to adjust historical figures for inflation, providing a clearer picture of real growth or decline. Worked example, groceries index. Let's consider a practical example involving grocery costs. Suppose the cost of certain groceries in June 2017 was £120, and this month is designated as our base month. In July 2017, the cost of the same groceries rose slightly to £121.80. We can use index numbers to quantify this change. To work out the index number for July 2017, we apply the formula cost in July, cost in June, and 100. This gives us £21.80 per 100, 101.5. This index number of 101.5 indicates a 1.5% increase in grocery costs from June to July. Now, imagine the index number for these groceries in August 2017 was 98. To find the actual cost in August, we use the formula cost in base month, new index number /100. So, £120, 98 for a 100 equals £117.64. This shows a decrease in grocery costs in August compared to the base month, reflecting potential sales or price drops. This type of analysis helps consumers track their spending and identify periods of higher or lower costs. Worked example, minimum wage index. Let's examine another real-world application, tracking the national minimum wage. In 1999, the national minimum wage for an adult in the UK was £3.60 per hour. We will use 1999 as our base year to calculate changes over time. By 2015, this wage had increased to £6.70 per hour. To find the index number for the adult minimum wage in 2015, using 1999 as the base year, we calculate £6.60, 360, 100, which results in approximately 186.1. This significant increase reflects policy changes and economic growth over the 16-year period, demonstrating the power of index numbers to highlight substantial shifts. For young workers, the minimum wage in 1999 was £3 per hour. If the index number for young workers in 2015 was 176.3, we can determine their actual wage in 2015. Using the formula 176.3 by 100 equals 5.289, which rounds to £5.29 per hour. This shows a substantial increase for young workers as well, though potentially at a different rate than for adults, illustrating how different groups can experience varying economic changes.
Summary. Well done. You have completed the course Calculating and Using Index Numbers. You should now be familiar with Introduction to Index Numbers, Calculating Simple Index Numbers, Interpreting Index Numbers, Using Index Numbers for New Values, and Practical Worked Examples. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.